Okay, so hello everyone to today's Wonders of Chemistry. Sorry I didn't, say it last time, but forget it anyway. It was just only the pilot episode. Anyways, today we'll be talking about chemical reactions, everyone. Today we're going to be talking about chemical reactions. So anyways, before we go down to like all the specific types and stuff, I just want to get the simple basics of chemical equations. Oh, okay. So simply put, chemical equations is when you put more than one element in the periodic table into equation. But note, unlike mathematical equations, which most of us are familiar with, instead of an equal sign, we use this arrow, which means yielding to. Well, it's yields to. So using my equation here, one calcium, using one calcium here and two chlorines here, due to the fact that both of those actually due to their placement in the periodic table, they yield to calcium chlorine. Chloride. Sorry. And note, whenever you want to write their name, calcium, just write it like this. Calcium chloride. Well,
calcium, the I after the C.
Anyways, here's a bit here. Instead of saying chlorine, you say chloride. Why? Because usually the elements are like at the end. They usually go with the suffix "ide." So wherever it's oxygen or fluorine or whatever goes in the back, it always ends in "ide." Always this. Please note this, or else you'll fail pretty horribly in a chemistry test when trying to write down the actual pronounceable name of chemical equations. Now anyways, now we got that through. Now I just want to talk about a little extra bit of chemical equations. A little bit, it's a bit of part of the basics, but it's also a bit of hand. So first I want to introduce you to coefficients. You see this big number here? This big number here is a coefficient. Basically describes how much of that specific molecule are there. So which means in this case we have two hydrogen molecules. And how does that work? Well, I'll just simply put just have 2H2 plus 2O, and then bring it to 2H2O. And where did that 2 go? It's still here, but why? This brings me to my second factor. Subscripts. You know this 2 here, right? That's like a little bit below the H. That is a subscript. Subscripts, like coefficients, also describe how much of a molecule there is, except that it only does it for a single element that it's right next to. In which case, if this is singular, there will be 2 hydrogen molecules. But rule of thumb, when there's a coefficient and there's a subscript next to the element, in order to find the amount of that element there is, you have to multiply the subscript by the coefficient. So therefore, there'll be 4 hydrogen molecules in there. All right. So now we got those simple things down. next thing I want to do is I want to go over some little details that actually you may run into in your chemistry class whenever the teacher gets pretty stickly about details. So first thing is that remember the 3 elements you learned: solid, liquids, and gases. Solids, liquids, and gases. Not the 4th state of matter, plasma, nor the 5th state of matter, Bose-Einstein constant state, but those 3, right? You have to apply them to there. Except that there's going to be a 4th one into that equation. But unlike of those other 2 state of matters that I mentioned, it is not plasma. Sorry, plasma does not fit in chemical equations. Instead, it's an aqueous. And I believe everyone here will be wondering, the heck's an aqueous solution? Aqueous is basically kind of like a liquid, but it's basically anything submerged into water. So for example, hydrogen chloride here, right? Just adding 2 there. This is an aqueous solution. And yet there are no bits of oxygen there. But it's still to be but still enough to be partly dissolved into water. Like for example, this is basically made whenever you try to spin a cup of water full of salt. And also the same happens when you have sugar too and all that other stuff. But anyways, whenever writing stuff down, you need to put the fact that whether it's a solid, liquid, gas, or an aqueous right over here in parentheses, and like a little bit of an abbreviation so that you don't have to write down the whole thing. Because trust me, writing down the whole thing's a complete pain. Like for example, iron will be listed as a solid. Mercury will be listed as a liquid. And an oxygen will be listed as a gas. So here, just to give you a bit of a visualization of what you can do, just please note, whenever the teacher asks for it, list whatever state of matter that each element is in. Please note that. Anyways, now we basically got all of the simple stuff out of the way. Now let's actually get to go to the more complex stuff. For instance, now we're going to go into the types of chemical reactions. And I'm going to start with fairly the simplest of all of them, combustion reactions. Combustion reactions. Simply put, it's a reaction where the product is usually carbon and water. And it's usually both. Not one or the other. It has to be both. An example of this is C3H8 plus 5 oxygen. And that yielding to with a bit of a combustion reaction for energy equals 3 carbon dioxide and 4 waters. So here you got yourself a reaction of a combustion reaction. Whatever comes out, it's always both carbon dioxide and water, not one or the other. And that's what most people get confused with. Like if something just enters water, it's like, oh, it's a combustion reaction. Guess what? No, It has to be both. And the next one is very ironic from what I said earlier that this is the simplest reaction. Well, guess what? This is actually one of the two most simplest reactions you ever find in chemistry. Synthesis reactions. And synthesis, or you can call it combination, however you want, it's just two elements being combined together. It's simple, really. Like see, NaCl, no, sorry. Na plus Cl yields to salt. So this is a simple synthesis reaction. But if you want to go to the opposite, the other simple thing is it's decomposition. And no, this does not have any other name other than decomposition. So an example of this is hydrogen peroxide. Everyone's least favorite element because of that cliche scientist stroke everyone knows nowadays. Now going to here, if you want to decompose this, you're like, oh, you just basically split the hydrogen and the oxygen. No, because just saying the output can still have molecules in it. It's just that it has to be the right amount. So in the end, you get 2H2O. And note because there's 4 of them, 2 get out and 2 stay. So therefore, we have a single oxygen atom just floating by, and we get the rest of our decomposition. So quick trivia: synthesis, combining something, and decomposition, taking something apart. And now that we got those down, let's say we're going to some of the most slightly controversial ways of chemical reactions. I'm going to be starting with single displacement. And it's a bit hard to explain, so let me just write it down for you. So we have zinc and two molecules of hydrogen chloride. You're thinking to yourself, how can this actually go by? Well, the answer is you can do a little switcheroo. The hydrogen goes away, and the zinc combines with the chlorine to make zinc chloride. But our sad hydrogen gets pushed out, and only to just sit there by itself, all lonely. And that is single displacement. Basically, it's switcheroo with only one element. But you're wondering yourself, is there more? The answer is yes, there is more. And that more is double displacement. And instead of just one molecule, we have 2. And we have 2 only. No single elements being stranded on their own. Hydrogen chloride plus sodium oxygen hydrogen, whatever it's called. We have this here, and we're still wondering how does this even go by? Well, again with the switcheroo, except that this time 2 elements are doing the switcheroo. Hydrogen is going to this equation, while sodium is going over here, taking both their places and making salt and water. What are you expecting it to be HOH? Well, you're wrong. You're wrong. Hydrogen atom makes 2 hydrogen atoms, and with 1 oxygen atom remaining, it creates water. And with that, my dear friends, is the end of this video. Well, thank you so much for watching. Please, if you like, please subscribe, and we'll do more videos next time. Thank you, and good night.